Hello and welcome. My name is Nidhi Bhatt. I am Division Head of UIX at Texani and the moderator for today's webinar. I would like to start out by thanking you all for joining us today. Although Teksun and Napino have worked together for a number of years on various categories of projects, this is our first time hosting a webinar together. We will be recording this webinar so that you all can have access to the valuable information shared during the presentation. And we will send out also necessary links and with the automotive industry rapidly evolving, we felt it is crucial for us to come together, exchange our insights, and introduce some exciting possibilities within the both teams. If you have any questions during the presentation, please free to type them into the chat box, or you can ask your questions directly to the presenters at the very end of this presentation. For those who are interested in learning more about ADAS and driver management system development, this promises to be an enlightening and informative webinar. We have a lot of expertise to share today. I would like to introduce Mohit on the side and Aman on Napino's side. I will first hand it off to Aman on Napino's side to introduce himself.
Good morning, everyone, to who has all joined over here. Myself, Mohit Agrawal, and I am head of technology at Teksun, bringing over 11 years of experience in developing innovative solutions across various domains like defense, satellite communication, security and surveillance, and automotive solutions. Today, we will be discussing Texan's services under ADAS and DMS portfolio. My friend Aman over here will give a short introduction on himself as well, and then we can kick off with the presentations. Aman, over to you.
Yeah, good morning. Thanks, Nidhi, for the introduction. So, it's a great day, and my name is Aman, and I bring experience close to 12 years in the connected car technology, especially working in vehicle tracking domain and the DMS and ADAS technologies for the globe, especially for India, US, and Europe market. And I'm equally excited to share my insights and experience of this evolving, rapidly growing, fascinating topic. So it's very, very important to know the importance of this technology first, why we are working on this complex piece of puzzle and why we are trying to bring this technology for the public. So it's imperative to know if you can see the stats across the globe. So there are 1.2 million plus fatalities are happening across the globe, which is causing 600 billion plus of economical losses. We need to understand what are the major causes to have to see these kind of problems. So it's important to understand the fatal accidents are happening because of several reasons. It could be distracted driving, it could be wrong lane departure, it could be running red lights. So we need to understand how we can bring such technologies into the play, which can do some measurement and help drivers to make some control, and we can bring the safe environment around them. So if we understand the stats, if we look around the slow traffic congestion condition in US markets, 60% of the cities are facing the slow traffic condition, which is maybe because of the smaller road conditions, and because of it people are taking wrong turns causing the road accidents, and the average driving speed is like 24.7 kilometer per hour, which is like something people may try to overtake any other vehicles and causing casualty to another person. So we need to look at these major problems here, and yes, with this technology we are trying to aim to improvise the entire driver behavior by 10x. If you look at the very alarming number, 24 people are dying over 100,000 people every year in US. So this is something we need to bring down, and this technology can definitely help people to make a safe driving behavior and drive in a proper lane. So without further ado, I would like to invite Mohit, who is a technologist and having good knowledge about the ADAS at a deep level. So I would like to leave mic to Mohit, and over to you.
Thanks, Aman. So, yeah, let's uncover the essence of advanced driver assistance system and discover what Texan brings on table in this particular area. Texan offers advanced driver assistance as a service to help drivers and vehicle sense, perceive, and respond to the environment around them. Our ADAS solutions can help improve safety, reduce driver fatigue, and enhance the overall driving experience. As the demand of ADAS grows, Texan is increasingly offering ADAS as a service to our customers, providing them with a range of solutions to ensure accurate functioning of ADAS systems and maintaining their optimal performance over time. Our solutions encompasses a wide array of use cases, some of which include lane keeping assistance, forward collision warnings, lane departure warning, lane change, decision aid, intelligent speed assistance, traffic sign recognition, traffic light recognition, and blind spot assistance. To do all this, we have a different set of services available at Texan, right from architecture design to hardware prototyping, camera driver integrations, CAN encoder decoder, AI model development and deployment of them, system integration, and system testing. So we cover all of these services under the ADAS portfolio. Similarly, on the DMS side, we do have in-cabin intelligence and explore innovative solutions that Texan has to offer in this domain. Texan designs advanced driver monitoring system solutions to enhance driver safety and comfort. Our comprehensive design and development services include accurate sensor placement, algorithm design and optimization, and system integration. Our DMS solutions optimize advanced technologies to monitor the driver's behavior, detect signs of drowsiness or distraction, and alert the driver to take actions, ensuring they remain focused on the road and enhancing overall safety and driver experience. Our offerings in this particular areas are Sachin, if you could keep to the thank you. So our use cases in this particular areas are driver fatigue, in which we take care of eye blink, driver drowsiness detection through yawn. Then we have mobile phone usage detection, like if any particular driver is driving the car and looking at the mobile downwards, we can estimate that he is using his mobile, so that distraction could be identified. Then we have seat belt on detection. If the user is wearing any seat belt or not, through object detection models, we can identify them. Occupancy detections help in the area if a particular seat is available or not. So this is more from a digital mobility standpoint. We have these features. Child pet presence detection is also present in our system. This is from the objective that there is an alarming situation in US that has been raised, that people tend to lose their pets in the car and they die out because of suffocation. So if a child or any particular pet has been identified to be present in the car, alarm can be raised. Then we have driver score on CAN data. So this is a crucial for fleet management and UBI kind of usage-based insurance, where we can identify that you have driver's behavioral pattern on how he's driving the car based on the CAN data, and we can sum up into a score. Again, on this particular side, on the development services, we have architecture design, hardware prototyping, camera driver integration, CAN encoder and decoders. Hardware is present, AI model development and deployment, system integration, and system testing. The hardware partners that we work with on this particular areas are Qualcomm, NXP, Renesas. On the AI side, it's TF Lite, ONNX, Sony, and OmniVisions for the image sensors. So to get this ADAS and DMS, we have carefully planted our cameras throughout the car from various use cases for surround view, park assist, blind spot detection, lane departure warning, pedestrian detection, and a dash camera for an internal view. So for each of these, there needs to be a separate camera module placed at a specific angle. Sachin, you can take us to the next one. Okay. So we discussed till now a lot on the size of which features we are providing right now and how we will be providing it through different camera placements.
Can you quickly skip back to the previous slide, please?
Sure. Yes.
Yes, thank you. Thank you. That's enough. Thank you.
Thank you. Perfect. So now we'll be discussing more on the AI models that we have developed to assist our ADAS and DMS use cases. Our first key feature is forward collision system. This system leverages advanced models such as YOLO and CenterNet for object detection, achieving an impressive mean average precision over 70%. It is designed to detect a wide range of objects including adult, child pedestrians, cyclists, and more. Now, the next one is Intelligent Lane Assist System. This system deploys models such as VPG-NET, which is Vanishing Point Guided Network, which is largely used for lane and road marking detection. LDNet, which is used for end-to-end lane marking detection and computer vision. This feature is used to detect the road and lane geometry even at speed of more than 40 kilometers per hour. This will also predict the unintended lane departures with either haptic indication such as vibration of the steering wheel or acoustic indications such as audio signals or spatial indications. Our third feature is moving off detection system. This component relies on YOLO and CenterNet models for object detection, delivering impressive mean average precision of 70% again over here. Then on the blind spot detection is it utilizes same powerful models to detect wide range of objects, including moving vehicles and bikes, especially when changing lanes or making turns. Sachin, you can take us to the next slide. Okay, great. So then we have automatic emergency control system. This system incorporates model like facial landmark detection and vital models to not only detect medical emergencies but also take prompt actions. This includes the collection of critical event parameters during an emergency event, and can be automatically initiate a call to ambulance services, roadside assistance, or monitoring stations to ensure swift and effective response. Then we have surround view, which takes advantages of models like perspective correction, overlapping removal, and image stitching. This feature brings a comprehensive surround view experience to life. It assists in parking assistance, but also facilitates reverse assist, offering driver a complete perspective of their surrounding. The seventh feature that we have is roadside recognition system, incorporating classification models like RSNet and EfficiencyNet, achieving a remarkable accuracy of up to 89%. This feature excels in detection and recognition of road signs, currently available for India. It further enhances safety by providing both audio and visual warnings. The last part is event data recorder, which word is self-explanatory. In this particular, we have a non-volatile memory allowing for future analysis and self-testing. So this is the overall hardware architecture that Teksun has laid out. We have designed a modular SOM board which has a B2B connector, V3H, SoC on it, TDR, Flash, eMMC, Ethernet, and PMIC, all gathered on a single SOM. To provide this whole ADAS and DMS solution, we have developed a carrier board, and on that carrier board, these three separate SOM boards would be sitting, taking care of different use cases. One SOM would be dedicated for front of the camera. The second one would be dedicated for blind spot and in-cabin camera related use cases. And then the third one is front near camera, side cameras, and rear cameras. Through this, what we can achieve is forward collision warning, lane departure warning, roadside detection, and emergency calls from SOM 1, from the SOM 2, blind spot detection, and drowsiness detection, and other DMS use cases that are present. And on the third SOM, moving of information system, surround view, display, and EDR, all those can be achieved from the third SOM. The design has been modular, so if there is not a requirement of a particular use case, that particular SOM could be skipped. On the carrier board, we have storage, MCU for for the real-time use cases, audio and other peripherals if you want to extend it to the in-car cabin experiences, then power biasing circuits, other IMU sensors for such as identifying any accident kind of a use case, or someone like tempered the car, or those kind of use case could be done with IMU. Other automotive connectivities such as Ethernet and CAN interfaces. Then we have displays for integrating with, like you can take an experience of this single board can also replace your infotainment system that is present, and it can provide you all the alerts and information right onto the screen, and it can also show an instrument cluster. Okay, Sachin, take us to the next slide. So this is to achieve all this, we discussed on the model, but essential part of it is how that particular SoC is helping us out on the image pipeline that is very crucial for the models as an input. On this, we have ISP, which is taking care of luminosity, brightness, and noise. Then we have IMR, which take care of distortion, rotation, and scaling, which like you would need to make sure on the image processing side to make these corrective actions on the image so that they are in a proper form factor to be applied to the model. On the computer vision side, we have CV engine, IMP core, CNN IP, DOF from the distance perspective, stereo vision again from the distance perspectives to it. Then we have CA53 processor for post-processing and ADAS functions like this. And then we have a separate hardware core as CR7, which will take care of vehicle communication and again ADAS functions. Deep dive into the computer vision section, we have again CVV engine, which has image formatting, object tracking, free space depth, and pre-processing functions. Then we have CNN IP. It has scene labeling, semantic segmentation, which is very crucial for the lane detection and departure, all those kind of use cases. And then object classification, stereo disparity, dense flow, optical flows. So this particular V3H SOM that we are using on this provides us with this inbuilt hardware platforms to have accelerated processings. Sachin, you can take us to the next slide. On the AI framework for ADAS, what we encountered is majority of the SoC companies, semiconductor companies have come up with their own hardware partners as well. But the main challenge is on the SDK side, that not every company that who wants to enter the ADAS and DMS kind of use cases or even enter into the automotive area, they don't have a right SDK to do this. What Teksun has done is prepared an AI framework typically for the ADAS and DMS. At the core of it, it is divided into three different segments. One is aggregate, which helps in gathering all the data from the car interfaces such as camera, CAN, and Ethernet. Then there is analyze framework, where we have laid out different uh, modules such as face detection model, landmark model, object detection model. So these would be inbuilt inside it. So the user would just need to worry on the sides of application area. We have installed the frameworks such as TF-Lite, OpenCV, scikit-learn, and all the data pre-processing libraries on top of it, so that anyone just needs to write, take care on the application areas. Uh, Rest of the parts are taken care of. On the outside connectivity part for cloud, mobile, or infrastructure, we have encoders for video, JSON libraries, OTA functionalities, interfaces such as, I can say protocols such as MQTT, HTTP2, TLS for security, BLE, Wi-Fi, and cellular for the connectivity perspectives. The middle layer is something that facilitates again the application layer on a different layer. The virtual sensor descriptor, virtual actuator descriptors are there to deal with the low level sensor manager modules, get those data and position them like in a very small database handler perspective or a buffer perspective, from where the application can just read the data without uh, worrying about the underlying infrastructure on the hardware aspects. Then again, we have algorithm wrappers, data visualization, and engine alerts identified so that they can be readily utilized for implementing any particular feature on the AI side that user wishes to. Similarly, on the connectivity side, we have deployed logic update wrappers, configuration wrappers, so that remotely you could control the functionalities of ADAS and DMS or any other engine alerts that you would like. So this could cater to multiple stakeholders within that particular OEM to understand live data or anything that could be helpful to enhance the business. On the top of it, it is just to explain that you could have various applications running uh, utilizing the same infrastructure. Thank you. That brings us on end to the presentation on the ADAS and DMS services side. Now I'll hand it over to Aman to discuss more on manufacturing, testing capabilities, and all the certifications that we are following to make a robust solutions.
Yeah. Thanks, Mohit, for sharing great insights about the core technology part of the ADAS. So, folks, it's really important to understand the need of this technology, which is to save the human life. So, it's important to understand the quality standard, because the one section is designing the product. The second section comes how to manufacture the product to be used on the field, to be used in the car cabin, which has to run the real updates and compute data on the edge. So achieve the right set quality of standards and to make your device function flawless on the field, it is very, very important to know what kind of quality standard we have to achieve. So here we bring IATF 16949 standard, which is globally uh, uh, practice standard for quality management standards. And this framework has been adopted from different countries like US, Israel, Europe, and few more. So this framework help to follow the right practice to ensure you are maintaining the right set of quality standard in your device so that it functions well on the field and minimize the risk of malfunctioning. So if we do a more dive over the infrastructure that we are required with on the manufacturing front. So Sachin, if you can take to the next slide. Yeah. So here we bring our legacy of more than 2 decades into the manufacturing of complex products like ADAS and automotives. So here we have like a big infrastructure of 12 SMT lines and assembly lines. And the most important part is how we maintain the quality standard, which is required for IATF 16949. So we talk about the cleanliness in the room, like class 100,000, which is stands for ISO 8 standard as well, which means for every 1 cubic feet, you have not more than 100,000 of air particles, which is very benchmark standard. And I would say you can achieve ISO 1 as well, but it is good enough to work in automotives, in pharmaceutical industries, and like aerospace as well. And if we talk about more complex structure of your PCB designing, it covers the BGA components, like how how you are going to sustain the vibrations on the field for your vehicle. So how much of solder paste you are applying on your board. So we have to ensure during the SMT process only you are able to achieve the right set of quality standards. So we have inline X-ray setup as well, so that we can do the inline inspection of your boards. Yes, we have applied the right set of solder paste, and it can meet the right set of vibration on the field as well. Likewise, a lot of other factors like PCB cleaning, optical inspection of the boards. So there are multiple factors includes and contributes to the quality standard of IATF 16949. And I will talk more about the other factors which are important for you to understand the testing parameters. So if we take the next slide here. So testing of your product is very, very important, because once you have designed the hardware, it has to be tested within the lab. So one of the important tests is your functional test. Functional test is meant for the intended risk of your device. For example, your device has been designed to function on the field to capture the data for the ADAS application, means the outward facing world. You have to detect the pedestrian crossing, you have to detect the forward collision, you have to detect the signboard, speed limiter. So in that situation, these are the known risks where your device should actually capture and give the right outcome to the driver, which is sitting inside the cabin, and the operator who is anywhere remote location. So device should be able to send data over the cloud. So in that condition, you should have the right set of test environment built around, so that you can test your device within the lab itself before the final dispatch. In the same manner, where we talk about ADAS features, there are another feature of DMS, the driver monitoring. You talk about drowsiness, you talk about distracted driving, if driver is using mobile phone, smoking, drunk driving. So there are a lot of features. You have to ensure device is able to capture these parameters about the driver. Apart, there are GPS location, there are CAN data from the ECU port, and there are a lot of other factor, the clamping of device. So the mechanical fitment also comes in the functional testing of the hardware. Apart from this, there are more other tests which are unintended risk. Like one of the example that I would like to share, let's say there is a roundabout, and there is an inner circle and there's an inner lane where the vehicle is moving very slow, and there is an outer lane which is like a free lane also. So one vehicle is approaching from the outer lane to the roundabout, and there is a condition that this vehicle has the equipped with the ADAS system. So while this vehicle is approaching and there is another vehicle is moving in the inner lane, there might be chances your outer vehicle camera can sense inner vehicle is approaching towards it, which means it can sense the condition of forward collision. And if there is a level 2 or level 3 of ADAS systems equipped in that vehicle, it can cause the sudden braking of your car. So these are the conditions that we have to test. Otherwise, you can create a lot of problem in this field of vehicle and on the track itself. So to meet the right set of standard on the lab testing itself, it's very, very important. Another factor we talk about the environmental parameters, like if your device has to be used on the field, it should withstand all the ingress protection. It's about the water, it's about dust. So if you want to achieve IP54, if you want to achieve IP69, IP65, so during the mechanical design itself, you have to define your standard to meet the right set of expectations and the performance of your hardware. And we have a right set of chambers available to make sure your device is well complied to those design standards. Apart from this, there is an important test criteria would be the salt spray test. For the coastal areas where our devices are being used, to avoid the corrosion, you have to perform the salt spray test as well. So again, your design should well comply with those standards. In similar line, we have a highly accelerated stress test chamber. We have hot and cold environmental chamber. You have to ensure your device is able to withstand low temperature and the high temperature as well. So we are able to test our devices from -40 to +40 within seconds. So this is very, very important because in the daytime, if your device is connected in the cabin and your glasses are completely locked, so your outside temperature will be different from your inside temperature. Maybe it is your cabin temperature would be 2x or maybe 1.5x. So you have to use right set of components, your quality of material selection, your wire sleeve selection, and then testing those. The endurance test is again the important factor. And another important part is to meet the right set of expectation for your device to run flawlessly in the market. So you have to ensure all the electrical and electronic components in the vehicle are completely validated and well tested. So we have electronic magnetic interference test, EMC, EMI that we call for, digital test, analog test, air shard test. So likewise, there are multiple tests that we can perform. And apart from this, if we need to redesign any other test as per the immediate requirement of the market. So let's say if customer comes and say, I want to test my device, if it can give me the alerts within 1 second. So I have to run a test on the field to ensure my speed of my processor is working fine. And on the edge, I'm able to do the right set of tests. Apart from this, to sense the ADAS and DMS functions from the lens. So lens calibration is another set of puzzle where you have to do the darkroom calibration test to ensure the camera, which is having a angular view, let's say 130 degrees or 150 degrees. So it should be able to sense all the object accurately. If it is a person or a human is crossing the road, or if it is a bat or is a cyclist crossing the road. So unless it sense the object, it won't be able to give you the right results and right set of controls. So that's why testing is very, very important here. So moving next. So another criteria in terms of selecting the right component. So if you talk about the designing of the complex structure of ADAS or DMS, or I can say dashcam product. So it is harnessed with the high-end technological component. And after the widespread impact of the supply chain due to pandemic, it is really difficult to get your component supplies on time. So here we bring our expertise to buy 75 million plus USD of components annually. And if you look at the stats that we have covered so far from our connects with our supplier, globally available suppliers. So we are connected from our suppliers from 15 plus countries, and we are dealing in 30 plus categories. So device is not just about electronics. It includes your electronic component, which are your active component, passive component, electrical supplies like batteries, and the chemical supplies like conformal coating, your solder paste, and any cleaning agent you talk about, your wiring harnesses, your sleeves as per the standard of automotives and maybe standards of US and European market, your connectors, your labels, your screw, mechanical housing, camera, lens. A lot of things are involved in the complete box build. So here we talk about more than 30 plus categories where we are involved with our supplier across the globe, and we have very strong connect with our global suppliers in electronic supply chain. We talk about Qualcomm, Renesas, Arrow, Avnet. So we hold a good supplying buying power where we can control our allocations and we can give the commitments to our buyers. Like we can provide the right product at the right time at the right place. So this is what the power we bring in the supply chain role. In fact, we also have a good infrastructure for the inventory management, because when a buyer is investing a lot in such a high-end technology, so definitely they want to achieve the right set of ordering and right time to market your product. So in that situation, they always want to know what is my right cash flows if I'm investing in the inventories. So in that situation, we have invested a lot in our internal real-time tracking of the inventories, plus the right set of quality control. So whenever we receive the material, we ensure the material received is completely quality checked. We use the X-ray inspection technology, which itself sends our components within minutes with the counting with 99+% accuracy. So the advantage our customers get is we are able to share our stats and the real-time inventory with our customers. So this is how we are able to have the inventory of 12 million plus USD, and to accommodate that we have a large warehousing area as well. So warehouse is not just about having the infrastructure, concealed environment. It's all about the environment where you are storing your material. So we are having the temperature and humidity controlled area, so that whenever the customer is required with some audit, so they always look at the condition where the material is packaged and how our system is working in place. So forward to next slide. So as a wrap up session, uh, as I mentioned, the quality is very, very important here. So to achieve that quality, we have adopted a lot of quality standard and we stringently follow all those standards. So we cover IATF 16949, ISO 45001, ISO 18001, ISO 9001. So it's all about, if you are having all the quality standards in place, your right expectations can be met in the markets. Without it, there could be a lot of gaps and you may fail in the market as well. So that's all from my side on the manufacturing front. Thanks Mohit for co-joining me. Thank you.
This.
Thank you, Aman and Mohit. Thank you everyone for participating. As mentioned, we will be sharing link to this presentation and the recording after the webinar. But for now, I will open up the floor to questions.
Yeah, good morning and good evening. This is Olik from SRM Technologies. Can you hear my voice?
Yes.
Yeah. I have a doubt in traffic light, traffic signal recognition in ADAS. So may move on to that slide. I think so in ADAS. Yeah, about before slide. Yes, traffic signal recognition.
Right. Sachin, if you could take to this slide number.
I think 2 slides before that. I think so. Good. Before that slide, you can explain that ADAS, correct? So, what are the use cases in ADAS? Traffic signal light, and then you can told like 70% above map. Like one slide is there. I got that number, slide number.
Sachin, we are talking about
traffic light recognition. Yes, I think here traffic light recognition you are mentioned, correct?
Right.
Yeah. So I have a doubt on that. Okay. If traffic light recognition, yeah, before that slide. Before this slide, yes. Okay. Okay, anyway, I'm asking this question to you. So if it is traffic light recognition, what is the speed limit or a distance from traffic light it will recognize?
Currently, it is at 10 meters we can identify, and the speed
10
is
meters.
within 10 kilometers to 15 kilometers.
Okay, understand that. So, yeah, understand that. Okay, yeah, thank you.
Thank you.
So one more question, sorry, you are doing only for traffic light recognition or any other vehicle control with that integrated in ADAS oriented features like like I want to ask about like by traffic light recognition you are applying a speed limit or speed limiting control or brake control or any other things integrated with that?
Currently, we have no taking control. Sachin, I'm getting a feedback and
Sorry, I got it.
okay. Actually, I'm getting my echo back, so I just need to see. Okay, so just to answer just currently, we are not taking control of any particular inside. It is just at this particular level we are at level 1, where we are able to identify situations and showcase to the driver either on the screen through visual warnings or through audio messages. There is no control as such being taken care of the vehicle right now.
Thank you, Mohit. Thank you.
Thank you.
We have questions in our chat box, Mohit and Raman. Uh, Let me pick one of that. How does Teksun ensure the accurate functioning of ADAS systems over the time?
Okay, understood. Thanks, Nidhi, for this question. Currently, the answer is I can structure it into a three layer answer to it. First of all, how it is designed. Second, how it is manufactured. And the third one is how it is maintained. So it will require answers in three particular sections. On the design side, we follow the V model, which is on the left arm of it, you can consider requirement gathering, system design and development, and software development. And then on the validation side, which is on the right hand side, functional calibration, functional integration, and software integrations are there. So all these methods in V structure are followed meticulously while designing the system to ensure the quality. And the second part is on the manufacturing of things and testing of things. So everything that goes is as per SAE J1455 standard, which Aman briefly discussed on the sides already on the what I can say is a test facility slide. Aman, if you would like to throw some light again on that particular area.
Yeah. So, as I mentioned in the previous slides about the quality standard as a part of IATF 16949 standard, in a similar way, SAE J1455 standard is meant for the environmental standard for your product. So, which basically covers your temperature test, where we talk about a temperature cycle test, thermal shock test, thermal stress, where we talk about the hash chamber as well, humidity test where we talk about the environmental humidity at a certain parameters, and the salt spray test, and exposure to the chemicals and oils. So highly exposure of splash testing is done to achieve that particular test, and dust and the scent test as well. So likewise, because just with one example, so if we take the example of this ADAS technology only, so where we actually talk about a cabinet which is like mounted in the cabin. So we have to ensure your mechanical enclosure should withstand the humidity, temperature, and vibration in the on the field. So which means if your driver is having the heavy duty vehicle and it is doing the off driving, so he should not, your device should not fail to fall off. So we need to ensure it should withstand all the difficult condition in the field. So this standard is meant for these kind of environmental tests.
Thanks, Aman. And Sachin, if you could take to the testing slide instead of the standard one. So that would, yeah. So
Yes.
these are the facilities because of through which I can say we are able to satisfy the high manufacturing standards on the side of SAEJ 1455. And that was the second layer. And the third layer of it, what I can answer on that particular side is ADAS is all about the AI models. DMS is again about all that. So what we do is these all models are regularly tested, updated, and any necessary maintenance to the potential issues are taken care of. We have a full-blown AI pipeline ready, where AI pipeline for training is ready, and also MLOps pipeline on the cloud is ready, where everything on the sides of data gathering, reprocessing, and the data labeling. The fourth is data training, and the fifth becomes data, a model deployment. So all this stuff is being taken care autonomously. So once a model is out there in the market, there would be obviously we'll be getting more and more data, and based on that, a continuous model will keep on updating and being deployed. So that's how in three different layers we are taking care of a matured solution.
Great. I think for the population.
More questions. Let me pick one. Can you explain the key elements involved in DMS solutions design and development process?
Okay. What I could say on this particular question is, again, as I answered this in the earlier one on how we are maintaining the models up to the date, is that we have on the AI front a built-in a custom-made pipeline that can be scaled and trained for any use cases with right data set. So at the crux of it, it's all about generating more and more data, labeling it out, and creating a right model out of it. So this is an ongoing journey, and in for that we have created that MLOps pipeline, which enables us to keep on improving the DMS solution. And at the core of this DMS solution, what we have done is the AI does its part on the side of facial landmark detection and all. But what we have done a lot, you can say, invested a lot of energy is human engineering aspects. Like AI model can just give you that a mouth has been opened up, right? But now in a use cases, a person could be singing in the car at a loud noise that can't be identified as a yawn, right? So that's a typical thing that a average yawning cycle is 4 seconds, right? So if a mouth has been opened from 3 second to 6 second of a kind of between that, then only you identified it as a yawn. Then again, different perception is on the eye side. AI model can help you understand if the eye has been blinked or not, right? But a popular belief would be that eye would be closed most of the time while a driver is asleep, but that's not the case. You could take an example of yourself that when you are driving a car, if you're feeling sleepy, you're going to fight that sleep and keep your eyes open for a lot of time, right? So generally, as a human nature, it is in a minute you are gonna blink your eye 5 times or so. So if we are not seeing any eye blink in that particular time or that is abnormal, we can identify that a driver is fighting towards that particular scenario. So that can categorize into drowsiness or fatigue for the driver. So a lot of human engineering when it comes to driver monitoring, a lot of human engineering goes into it. uh, DMS does its part, but like AI, but a lot of on the statistics side are also needs to be integrated. Okay, if there are no other questions coming in, I can even stretch a bit on this DMS. I got this part that on the DMS side, what Texan has done very innovatively is to identify drivers' vital signs through a remote PPG technology. You must be aware of the PPG technology uh, due to the COVID era, in that you were able to get the pulse oximeters, right? Which provide you heart rate and the blood oxygen. It essentially use the PPG technology. What Texan developed is the remote PPG technology, in which the camera pointing just to the face, we are able to identify, like say, the RGB channels into different RG and B, and identify the flow of the color, and that flow of the color depicts the flow of the blood in your veins. And based on that, we are able to also get heart rate signals and derive blood pressure out of it, and also what we can say is blood oxygen. All this contributes towards driver's fatigue, which is really important factor from the point of view of fleet operators, because generally the drivers in the fleet industries are overworked out, and most of the accidents, the statistics, I currently don't remember the number, but the statistics is huge, saying that most of the accidents are because of driver fatigue. So that's one of the very innovative solutions that Texan has brought on that particular site.
Anybody else? Any other questions?
Yes, this is from Paulit. One more question from my side. Any functional certification done for sensors which is used in ADAS feature like camera or any other things?
Currently, as I said, Mr. Muhammad, on this side is that currently we are on level 1 on the functional because this is purely just as an assistance side of thing. We are not really taking control of any particular element inside the of automotive. So we haven't gone into that cycle right now, but we do understand that, and as a next level, we would be entering into the functional safety aspects.
Thank you, Mohit. Thank you very much. Thank you.
So I guess, Nidhi, we are at top of the hour right now, and if there are not other questions, we could conclude.
Yes, Mohit. So, thank you everyone. To learn more about Teksun and Napino, you can visit our websites. Have a great day. Thank you joining.
Thank you so much. Have a good day. Thanks for listening to us.
Thank you, team.
Thank you.
Thank you everyone
Thank
for
you.
joining.
Thank you.
Yeah, thank you all. Bye.
Bye.
Thank you. Bye bye.